Welcome to my channel. Today we are going to discuss about very simple activation function, step function, also called threshold activation function, which was originally used in McCulloch's neuron model. This one of the earliest activation functions used in a neural network. The idea is very simple. The neuron either fires or does not fire. Mathematically, the step function is defined as f of x equals to 1 if x is greater than or equal to 0, otherwise 0. Here, x represents the weighted sum of inputs. If the weighted sum crosses a certain threshold, the output becomes 1. Otherwise, it remains 0. This behavior is similar to binary switch. Because of this binary nature, the step function was mainly used in early logic gate implementations, such as AND, OR, and NOT gates. However, this activation function has a major drawback. It is not differentiable, meaning we cannot compute gradient for it. As a result, we cannot train neural network using gradient descent when this activation function is used. Geometrically, neurons with step activation creates a linear decision boundary, which is a straight line in two dimensions, or a hyperplane in higher dimension. To summarize, the step activation function is historically important and useful for understanding neural network, but due to its non-differentiability, it is not used in a modern deep learning models. Thank you.